there, and welcome to the Chapter 12 test review. This is going to be on statistical displays. It's going to be on textbook page 863 through 915. It's going to be more of a conceptual chapter review, and it's going to be very brief. So you want to be sure to write everything as we go. You can write shorthand notes about this specific table here. It's got the types of displays, and it's very important that you understand when each type of display should be used. So we've got bar graphs, and what those are used for is when you need to show the number of items in a specific category. So for instance, if we were producing data on how many kids liked math, science, or social studies, then we could also use a bar diagram for that. So that's the categories that you see there, okay? Then we have the box plot. The box plot, you have to remember, is information that's already been crunched, basically. You know how accountants talk about crunching the numbers. Well, these numbers have already been crunched, and it shows the measures of variation, also useful for very large sets of data. So if you don't want to list every single data, then you can show a box plot. So already crunched. Now with histograms, they're going to be very similar to bar graphs, but they are not the same as bar graphs because histograms show frequency of data divided into equal intervals. So the word that you're looking for if they ask you about which is the best data display is that intervals word. And really you can also remember that because we're comparing numbers and numbers. That's important for a histogram. So what that means is the example that they were given, or that we were given in the book at one point, was comparing how many kids did, or I'm sorry, what were the heights of kids ages like 8 to 12, 13 to 15, and so on. So you would expect these to be numbers, and then you would also expect the side numbers to be numbers. So this is like 50s, 60s, and so on. So that's a histogram, and remember there are no spaces in between either. The line graph will show changes over a period of time. So over a period of time is important for you to remember about the line graph. The line plot shows how many times each number occurs. So if you wanted to see how many times people sold, or how many weeks in a row or whatever he sold 25 books, the line plot would be helpful because you're looking for the mode, and that's got the raw data in it. You're also going to need to know how to read information from a box plot. So as you can see here, we have a box plot, one that I just made up, and I'm just going to ask you a few questions about it so that I know that you are ready to do this on the test. So for instance, you're going to use, for the next few questions, you're going to use the box plot that you see here. So if it says, and we're going to pretend, hold on, let me give you a category. All right, so now I've given you a category here. It says that this box plot is going to be about the height of dogs at 1 year. So I just made this step up. I want to make sure that you're able to read the information. So a sample question might say, what percent of the dogs are between 30 and 50%? So you would need to know that this accounts for 25%. This is another 25%, this is a 25%, and this is a 25%. So between 30 and 50, you're looking at 50% of the data, okay? And so another question that might be asked is going to be, what are the third and first quartiles of the data? So the third quartile would be 50, and the first quartile would be 30. So you would want to select the answer with that information. All right, so I added a little bit of information because it was about that particular problem. The question could also say something like, what percent of the data is between 50 and 60? So the percent of the data then would of course be 25% because each set from here to here, like I notated in pink here, is 25% of the data. Here you have a line plot showing the number of teddy bears collected by the student council, and the first question that you want to be sure that you're able to answer is, what's the mean of the data? So you need to know how to calculate the mean of the data, so I'm going to do that briefly. All right, so off to the side, you can see where I have listed the data pieces, each one of the numbers so that I can add them easily. Now, as you can tell, I didn't use the raw data. I went, okay, 10, 20, and then 20, 40, 60, 80, 100. That was counted from the 20s column. There were no 30s. We had 40, 80, 120. 50, 100, 150, and then 60, 120. So when you add all that up, you get 510, and then we're going to divide that by the number of data pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now I'm going to divide all that by 15. And when you do that, you get 34. So that's a nice number for us. So you do need to know how to calculate the mean. Also, with the same type of data, all right, so the next piece is going to ask you something along the lines of what is best used to describe the center of the data. Now, this question is pertaining to this set of data. So on the left, I've listed the mean, median, mode, and range for you already. You don't need to calculate those. I'm just giving them to you. And when we look at those, we want to figure out what's the best representation of all the numbers. So if we look at the numbers here, we can see that all of these numbers, right here, that all of these numbers right here are in the center of the data. There's 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of the 15 pieces of data fall between 20 and 40. So it wouldn't really be fair to say 20, and it wouldn't really be fair to say 40. But that's when our mean is probably going to be our best center of the data. So that's the best center of the data. So you don't want to just read that question as the center and say, oh, median. And one that you should be able to cross off the list right away is range, because that's not a measure of center. That's a measure of variability or variation. You also need to be prepared to answer questions about the shape of the data and the distribution. So for instance, this data would not be symmetrical, or symmetric rather, because you can't draw a line down the middle and see the same on both sides. There is a peak at 20, so that could be used to describe the data. There is a gap at 30, so that could be used to describe the data. So that should pretty much take care of the line plots, or line graphs rather. All right, so here you see which is the appropriate display to show, and now I've given you two situations. The first one is the ages of teachers arranged by intervals. So I'm going to first start by putting a big bubble around the important word here, because all of these can be put into different graphs with different ideas behind them, but because this said intervals, the best graph for this one is going to be a histogram. Next, we have the height of a sunflower over the past 6 weeks. So remember that one requirement that we had. I'm going to go back a couple slides here. Notice, remember, see in blue here we have, I'm going to underline it in yellow, it shows change over a period of time. So a line graph is going to be the correct question, or the correct answer here. And the reason that is true is because it says over the past 6 weeks. So because this has to do with time, change over time, that's why a line graph is going to be the best display. All right, so here you see another line graph, and this one's a little bit different than the last one that we looked at. So if you were asked to describe a line graph, remember before it was not symmetric, we described any gaps and so on. So this particular line graph, remember, is going to be symmetric. So you do need to know what symmetric looks like. And basically, if you draw a line right down the middle here, it looks the exact same on both sides. That's what makes this symmetric. Also, you'll want to notice that there is definitely a peak at 30, because you have 1, 2, 3, 4, 5 at 30. So the peak will be at 30. And now when you're talking about which number best describes the measure of center, it's definitely going to be the number 30, because that's where the majority of the data falls. All right, so here you have a histogram, and this histogram, you can tell it's a histogram because you see the intervals on the bottom here in orange, and it's the cost of genes in a certain population. It could be a classroom. So we've got the different costs listed here, and the questions may be, what was the cost of the least number of genes? So as you can tell, the bar that's the lowest is going to be the 120 to 149. So for a question that asks you what the cost of the least number is, that would be 120 to 149. That would be the range. And if they say how many pairs of jeans cost more than $60, that's when you would add up the 10 here, let's see, 4, we'll call that 5 here, and the 1 here. So 10 plus 5 plus 1 is 16. So if they're asking you how many pairs of jeans, or how many people had jeans that cost more than $60, then you would have to add all those together and you would get the answer of 16. So you just want to make sure that you can answer questions about a histogram similar to that. And last but not least, you have a question here a line graph, and it says the graph shows test scores of student averages. What is the best prediction of what is the best prediction of an average of 3.25? Sorry, that's a typo in the question. So we're looking at a prediction for an average of 3.25. So that's going to be about halfway between 3.0 and 3.5. So as you can see, I've drawn a line there to go up to where 3.25 would hit its prediction. And out of the numbers listed here, it looks like this one would be closest to 29 because see, this is 30, and so 29 would fall right about here. So that would be my answer for that one, 29. You know, it's not going to be 32 or 34 because our prediction doesn't quite come up to the 30, it's just below it. And notice it's not way down here at 25. So that's how you eliminate the choices and get H, 29. So like I said, this is going to be a brief chapter 12 test just to make sure that you have all the information that you need to be able to do well. And then we'll move on, and we are getting ready to go ahead and start the 7th grade book. Woohoo! I believe in you. You can do it. And I'm going to leave you with this final cute little meme. It says, the human brain is awesome. It functions 24 hours a day from the day we're born and only stops when we're taking an exam or when we fall in love. So don't let this be you. I'm certain that you're going to do wonderful, and I will see you in class.